Hello, everyone. Sorry for the dramatic cut of music there. I hope it wasn't too much of a shock. Welcome in, everyone. It's a Wednesday afternoon, so you know what that means. It means that we're doing another discipline deep dive. If you're not familiar with these discipline deep dive events, well, don't worry. I always introduce the concept at the beginning. This series of events is brought to you by Intergames. Intergames is an organization that works really hard to make the UK games industry just more accessible to everyone, no matter what your background. There's a really strong belief that if you come from a low income background, if you don't have access to certain resources, or if you've just got any sort of accessibility issues whatsoever, that shouldn't stop you from being able to have a career in the games industry. And what we try and do to sort of support that is we have a series of events where we've basically looked at the entry level sort of jobs and specs in the games industry, especially the UK games industry. And we've tried to understand what are the requirements for those entry level jobs, what are hiring managers and sort of talent teams often looking for in candidates. And then what we've done is we've compiled a lot of those jobs into like a single website. So if you go check out our entry level skills hub, which we'll just put the URL scrolling down there. The entry level skills hub is like it's a database of jobs that exist for sort of UK games industry at the entry level. And for each of these job titles and roles, we take a look at what the requirements are of those roles, what are the common skills and knowledges required for someone to kind of at least have a chance at getting, through the application stage and getting into sort of recruitment in those roles. And then what we've done is, once we got that information, we said, well, where are you going to learn that stuff? If you don't have access to that education, if you haven't got that background, if you are from a low income background, that potentially means that you didn't have access to certain educational resources when you were younger. So how do you get access to them now? And for free, no less. And so that's exactly what these live streams are. For each one of those bullet points and skills and knowledges, we're trying to bring someone in to sort of talk on any one of those and just really open the door into like, how can you know more about that subject? Where could you possibly start? Where could you go and teach yourself those skills if that's the next step? And so today we're doing that in programming. So we always split our events into kind of 8 major disciplines. If you take a look back through our last few live streams, you'll see that we've done various different ones, whether it's in design or art or animation or production, but today's one is sort of in the more sort of coding and programming area. We're going to talk a little bit about sort of computer science and its applications in games development. And as always, I'm not going to tell you how to do that. No, it's never me. As always, we have a wonderful guest to join us today. Today we have Husband joining me on stage. Husband is going to appear right next to me right now.
Hello,
Husband.
everyone.
How you
Hello,
doing?
Jonas. Yeah, I'm doing all right. Alhamdulillah. Thank you. Thank you for having me. I really appreciate it.
No worries. So obviously, yeah, hi in chat, everyone. We're here to chat today. Husband's got is going to sort of do a bit of a presentation on the subject of computer science and its application in games development. And then once we're done with that presentation and talk, if we've got time, we will jump into a Q&A section. So if you've got any questions, feel free to put them in chat throughout the entire thing. I will be reading and keeping an eye out, and I'll try and make sure that any questions sort of get addressed. But then there's a focused section at the end as well. So if there's anything on your mind, that's absolutely the time to say it. But feel free to chatter throughout the entire thing. I'm sure there'll be some excellent commentary, and I'm sure people will find some slides interesting and whatnot. Now, Husband, can you share your bits and bobs with me here in our little platform?
Yeah. Sure.
And just hello to particular people in chat, by the way. Hello, Chia Hui Chow. Hello, Tyler Charman Smith. Hello, Zahib. And hello, Samantha Draws Stories. And if you're watching us in the future, hello to you in the future. Do you still code out there? Who knows?
I was gonna say I really hope the stuff ages well. Otherwise, it's gonna be a problem.
Yeah. Tomorrow, AI just gets so advanced that actually...
Oh no! Don't say that. However, what I will say is, if you're from the future, I can only apologize if somehow we have advanced beyond the stuff that I'm showing here.
Well, fingers crossed. Fingers crossed this is applicable for at least the 1 hour that we're sat here and we're not completely timed out by technology by the time we're done. Right, I'm going to give you your slides and I'm going to leave you to it. Everyone, please be very kind and give a warm welcome to Husband and Husband. The floor is yours. Best of luck.
Thank you very much, Jonas. So roles and applications of computer science in game development, which is a very wordy title, and hopefully this will be somewhat of a any percent kind of thing. I think one of the troubles with putting together a talk like this is because it is such a vast field, as I'm sure some of you can imagine. And so the way I've structured this talk is hopefully it'll give you a bit of insight into the kind of not only the fundamentals kind of everyone will need, regardless of what role you serve in a company or at what scale, whether that be indie or AAA. But the hope is as well, like you'll find perhaps either a discipline specifically in programming that you're interested, or it might be you're interested in all of this stuff, in which case you wish to be a generalist. So that's me. Let's do the more professional version of this. So I'm Husband. I'm an independent games developer. I have roughly around 10 years of software development engineering experience. Even though technically I have 17 years of graphics media animation experience, I would definitely say I'm more of a programmer and designer at heart. I'm currently working on Rogue Eclipse, which was recently unveiled at Summer Games Fest as a part of Outersloth. And the last thing I'll say is apologies for the graphic design is my passion nature of this presentation. And so I definitely have operated more in the, shall we say, the small end of the scale, but I actually transitioned from a previous industry. And from that industry, I worked on a variety of different things, anything from virtual reality to embedded systems. So to some extent, I came from a more traditional software engineering background and then transitioned into games. I'd also like to give some acknowledgements to contributors to this talk, which would be John Price, Jack Barnes, Joel Otterson, and Ruben Bradley, who are all very kind and generous with their time in terms of reviewing the talk and going over some of the subject areas, just simply because they are really talented programmers and they also have a lot more experience in some of the subject areas I'm about to get into. Sound warning, this is literally just a snippet from the project I'm currently working on, so prepare your ears. So, right, with that, let's jump in. So, for starters, before we even talk about programming, let's talk about the scale of it. So, if you're looking to get into games, you could end up in independent games development, or you could end up in AAA development. I mean, there are in-betweens as well, because you have things like III and AA. Those terms pertain to the budget sizes of those games and those projects, but also the scales of the team. So for AAA, you could be in a team of 100, 200 potentially. Whereas in indie, it could literally be yourself, and it could just even be 2 or 3 other people you're working alongside. The biggest difference is generalization versus specialization. In independent games development, you're generally, it's in the term, you kind of have to be a bit more of a generalist, where you'll have to problem solve in a variety of different ways. Whereas the larger the game, the more specialized you'll need to be. And generally, as it goes, in independent games is smaller teams, more agile. AAA, because of the development timescales, there are generally less surprises and more planning. So before we even start in programming, so apologies, this talk is really going to go from the ground up of before you even start using programming languages all the way to the different roles. So really, fundamentally, it's about pseudocode, which is effectively figuring out how to logically lay out a series of steps for how you're going to execute something. Building on from that is the process of procedural abstraction. And the whole idea behind procedural abstraction is essentially that an entire system is just made up of a series of black boxes, which are all composed of pseudocode, and it's a chain of those, and it's a network of those that then perform the application. Another fundamental principle is don't repeat yourself. The main reason behind that is because it's very common in programming where you may see the same problem come up over and over again. And effectively, you just want to ensure that if you see multiple problems that require the same solution, you come up with that solution that can then be applied across each of those problems. And then the last thing is, even though there are programming languages, and we will get to this further in the presentation, the languages are merely the means by which you apply these things. So it's not like, oh, which language is better or anything like that. It's more like it's going to be contextual to whatever problem you're trying to solve or whatever application you're working on. It's as simple as that. So even though you could say, oh, learn these languages, but it is, particularly in game development, incredibly contextual. So the other side of it is, so we've gone over kind of the structure in which, the skills that you'll need to apply independently, right? But then there are more broader processes as well that you have to be a part of. You'll notice that I have specification here. And within that specification, you'd see I've even broken it up in terms of different things, because at the end of the day, these things can all apply very differently. For example, if it's a technical implementation, that could be something that's generally applied to a tool that you'll need in the engine. Like for Rogue Eclipse, it would have been, hey, we need a tool that can produce like a planet that looks a certain way, and that's a very technical specification. Another example would be like user stories, as in larger projects when you have to fulfill a variety of different requirements. User stories are very useful in that you can use those to kind of define the type of experience that you're crafting. So for example, just like, well, we want players to have this kind of feeling. We want players who want to be able to, I don't know, be able to fish in our world and things like that. But that story of being able to walk and go into that world and like go over to, I don't know, like a pond or whatever and be able to fish, but like then that would be used as a basis for defining what a feature or like that would define design and feature, as in it would be from a gameplay standpoint, okay, we need to, the fishing has to operate in this way. And then that also gets translated into these are the things that the player will be able to do. So yeah, specifications are important. It's more like documentation and to some extent keeping track of the activities that you're doing. And it's less to do with programming, but they kind of go hand in hand. You need to understand where in the context of your project, particularly if you're in a larger team, what you basically need to be doing. Then the other thing is there are two kind of common models in game development. However, there are many other software development workflows that are used in other industries, but it is important to be aware of things like agile and waterfall and understanding how those processes ultimately impact the way that you work, where it's going to be something more linear, where you do something sequential and like until each of those stages are complete, you don't move forward, versus more iterative processes where basically you'll do something, but then you'll kind of go back and like restart the process a little bit to some extent, because you'll find that maybe the feature or like what was being requested doesn't actually fit within the vision of the game. Now we're going to go into general fundamentals. These, regardless of your role in the context of an organization, you just have to know these things. It's as simple as that. So in terms of the way that this is structured, we're going to go over basic data types, data templates, data structures, encapsulation, polymorphism, control flow, and performance optimization. Regardless of what discipline you ultimately end up in, whether it's network, gameplay, or engine programming, you have to know these things. And so apologies for any of you in the audience who may have experience with this or may already know some of these basics, but it will make sense in the context of how I apply these things. So in terms of fundamentals, for those of you who have already done programming, I'm sure you're familiar with all of these things, as in things like Booleans, which is effectively yes or no. You have integers, which are basically numbers that don't have decimals, and then you have floats and doubles. The reason why I've differentiated between float and doubles is because even though they are both technically like decimal numbers or decimal values, the length of those values changes. But either way, you'll be working with these data types. And the last one I put in there is vectors, and vectors are usually a makeup of floats or doubles. The main reason I bring them up in this way is just because, simply put, if you're doing anything in relation to like anything from tracing to doing distances or moving objects in the world, it's a fundamental data type. And also the fact is that that structure of a vector does get applied to other different types, which can usually be summarized into basically three variables. Then we've got data templates. And so, for example, for arrays, you'll see the graphic design is my passion showing through here. But arrays are basically a very straightforward way of storing a data type. So, for example, you could have an array of integers. So it literally means within that array, you can only store integer values, but then like you can change it as well, where it could be an array of objects. And so the example here is like within my array of objects, I've got these characters over here. Then there are maps, structs, and classes. And in the case of structs and classes, even though there are differences, obviously. However, the key thing is how it's the way that data is templated and stored. So, for example, in a class, you would have a character, and within that character, you may have things like health, you may have things like how much damage it can do. But the key thing from all of this is that you need to understand contextually how you can apply these things. And that's probably the through line here. It's more about the application of these things as opposed to just like knowing what these things are in concept. So then that brings us onto data structures. So for example, you have hash tables, and a simple example of that is key values. So, you would have a key of names, for example, and those names would then go into the bucket, and it's effectively an associative thing. So if I don't know, put Link from the Legend of Zelda, then like it's going to pull out all the information related to Link, for example. It's just a very straightforward way of being able to kind of store and associate information. Then these are more conceptual than anything else, but it's the fact that you've got trees, which are more hierarchical relationships, and trees have such a variety of applications, as I'm sure some of you in the audience are aware of, as in it's the fact that to some extent concepts like inheritance can be represented with trees. Likewise, or conversely rather, you have graphs, and graphs can represent interconnected relationships where you'll see it in a moment, but basically you'll have an object that could be connected to many things. which kind of pertains a little bit to polymorphism, and we'll get to that. But at the end of the day, again, it is about like being aware of these concepts. And then, I mean, some of them you can't just list off an example. They are contextual to the thing that they are applied to ultimately. So now we're going to talk about encapsulation, inheritance, and polymorphism. So encapsulation would be something like a character, for example. You would have a character class, so you'll see that I have basically a character. And then an example of inheritance would be, okay, one of these types of characters is going to be a monster. And then from that monster, I'm going to have a series of monsters. And so you have Spider and Cyclops. But because at the end of the day, they are templates and they all should be sharing the same kind of data. And then in terms of polymorphism, you'll see over here, I have health and magic. And the reason I've done it this way is because not all characters may necessarily need health. Not all characters would necessarily need magic. Some characters may not need either. So in the context of this, you'll see the player character has health and magic. You would see that a monster has health. And then within that, you'll see, well, because Spider inherits from the monster, that means it'll also have health. But not all monsters need magic, hence why I have added magic to the Cyclops over here. But then it may be I need a character that doesn't need any of those traits. So that kind of, in a nutshell, because like you can talk about things like encapsulation, inheritance, and polymorphism just like as these abstract concepts, but it's more about how they're applied. The other thing too is like, even though I have structured it this way, this may not even necessarily be the correct way of doing it. However, it's, again, the whole thing with game development, it's very contextual to what you're doing. So I've chosen to architect the character system in this way. There isn't necessarily a right way or a wrong way, but this is just to illustrate, simply put, how each of these concepts are, like, how you can just apply them and understand them in a kind of in a straightforward way in the context of a video game. Yeah, so that kind of hopefully rounds out the most of those core fundamentals you need, like in terms of concepts and elements. But then we've also got but then we build on that by looking at things like control flow, and control flow is effectively, applying those things. So simply put, it is logic flow. It is, for example, if X, do Y, else do Z. And effectively when you're doing control flow, it is really more about controlling the different states. And then within those states, if you're dealing with large data types, you'll need to use something like a loop. And within a loop, there are two very common types. There's a for loop and a do while loop. And in the case of a for loop, you'll present, you may have like 10 objects and you only need one of them. So you'll do for x equals 0, I plus x plus plus. Like, you'll want to go through each of those objects, and then you may have additional states you want to go into. But yeah, the main thing is that control flow is effectively how you would construct a function. And yeah, effectively games are a series of loops. If the player score goes above 10, game, they win, things like that. So yeah, apologies for that. That was the most convoluted way of explaining these very simple logical concepts that you'll need. And the final thing is you'll have conditional logic, branches, and loops all contained in what we call functions. And functions are effectively the black box that I was referring to earlier when it came to procedural abstraction. Lastly, there is performance optimization. I'm hopefully going to touch on each of these in the context of the discipline that you're in. But this is something you'll need to be aware of, because no matter what you're doing, it will impact the performance of the game in some way. And it's just important to associate how the discipline that you're in impacts the game ultimately. Right. Now we're going to go into the specializations. So in terms of specializations, and there are way many others beyond this, but I would say these are kind of the most common ones, because you have gameplay programming, you have engine programming, and then you have network and multiplayer programming. And yeah, we'll basically jump into each of those, but this is kind of a rough overview of the different kind of specializations we're going to go into today. So when it comes to gameplay programming, one of the really important concepts to get your head around is collisions and casting, because and even though we'll touch on this a little bit in the physics section, we're not going to go too in depth in it. But the whole idea of collisions and casting, it is effectively being used to determine contact and intersection between objects. And the reasons we have this is because it's more efficient to be doing something through this way versus trying to do it via the physics. And so effectively, the bottom line is bounding and overlapping objects. It's a cheaper way to not only check whether there's contact between objects, it's a way that we can also hook in events or functions associated with those contacts. And then like a simple example of that would be a trigger volume in a video game. So if we take this character over here, for example, and they enter this box, and this box basically can have some code linked to it or some logic linked to it that then causes something to happen. A common example is like if you're in a first-person shooter game, like in a single-player one, and you walk in through a door, it might be just before you enter through the door, they have a trigger volume. You enter it, and that will basically spawn the enemies on the other side of the door. The main reason to be aware of this is because collisions and casting are also the way, to some extent, things like weapons are handled in a game, but also it is kind of, it requires elements of geometry. So you kind of are dealing with objects and how they all intersect with each other. Which then brings me over to tracing and raycasting. And effectively, the simplest example is in a video game, say you fire a gun, that gun, like, you will basically fire what we call a trace. And that trace is basically a line that starts from the point, which would be like the barrel of a gun, and then it would go outward. And the way that line works is and this is where something like vectors having a knowledge of vectors is important, because you would take that point, you would then draw a line out from that point, and then that line, depending on how you've implemented it, because maybe you want that line to go through a wall because I don't know, it's something that can clip through anything, or you want it to intersect with a specific kind of object. Effectively, it is a fundamental way that, like, a lot of kind of the implementation of how we detect certain things in games, and hit scan weapons. And this would, a good example of this would be something like in Counter-Strike, when, like, you're using something like that, it effectively is running an invisible line from the player to the endpoint. And then along that line, it is effectively looking for whether or not it's hitting anything. And the main reason you have to kind of get your head around this as well is because ultimately the number of traces that you're running, what those traces can intersect with, that can have a massive impact on performance. And traces go even beyond just like the simple example that I've brought up here of a linear trace. You could also have something like a sphere trace, as in if you're playing a game like League of Legends or whatever, or if you're playing a fantasy type game where you have what we call like an area of effect attacked, you would use something like a sphere trace, because you would see the magical VFX, and then the VFX would go off, but in the background, in reality, there would be the sphere that's there, and that sphere is looking for a specific set of objects. But if the filtering isn't handled correctly on that sphere, you could end up in a situation where it's accidentally picking up the grass objects and the vegetation and everything around that. And then all of a sudden, if you have too many objects in a place, all of a sudden your trace goes from just looking for 4 characters, you are tracing accidentally 50, 60 objects, and only 4 of them needed tracing. So part of the optimization process for tracing is doing what we call filtering and caching, because filtering would be, hey, we actually only want to check if there are characters within this sphere. We're not interested in like whether or not there's vegetation or crates or anything like that within the sphere. And then conversely, you also have caching, and caching would be, well, we've already detected this character and we've already applied damage to them. We don't need to apply damage to them again. The context of that would be, say it's an area of effect attack that goes over a wider distance over time. The last thing you want is objects within that, or maybe you would, but you don't want objects within that to kind of get caught up again in that. And it's also a case of not repeating yourself. Again, going back to the fundamental principles, but you see how it all applies all of a sudden. It's the fact that simply by not repeating yourself, not only are you avoiding a situation where you're causing something that shouldn't be happening, but you are also saving on performance as well. Then in terms of gameplay programming, like in terms of AI and pathfinding, and again, this is something that's just going to be so contextual to the application you're working on, but the way that AI can be looked at is effectively one part logical processes and another part which would be algorithmic pathfinding. So logical processes, an example would be if you have like a finite state machine, which is effectively like just very linear logic, which again goes back to control flow, as in if the player makes a noise over a certain thing, I have detected them, else don't do anything, continue the control pattern. If I see the player, I need to do X, Y, and Z. So to some extent with AI, you have finite state machines, you have behavior trees, and those are kind of 2 architectures for building AI. The main thing I'll say in this is there isn't a one size fits all for AI. There are numerous different models, but 2 key ones at the end of the day are these. The other thing too is finite state machines can also apply to different things as well within the context of games. And that's kind of the main thing. It's more like you're simulating the logical processes that an NPC or computer character would have to do. Then there's the algorithmic pathfinding, and yes, there are things like A-stars and Dijkstra's algorithm, which are 2 different means by which you can pathfind towards a player. And part of those algorithms and why they're so widely used is one, both their applications and terms and efficiency in terms of being able to search for find basically the most efficient path to the target. You'll also notice I have something called an environment query system. And this is effectively something where if you look at this diagram over here, you'll see a whole bunch of dots, and like you'll see the ones that intersect the boxes are red and the ones that are on the ground are green. These are basically used to kind of inform the AI how to navigate the space that it's in, or rather what points in the space that it can move to. But again, it'll just give that data, right? Ultimately, it's the logical process that will determine what green point an AI will move to within a given space. Then to briefly go over optimization, and I'm just noticing the time, so I'm going to try to do my best to speed up. But on the optimization things, when it comes to gameplay, particularly when it pertains to AI, is the complexity of the tracing. How many objects, the types of objects, does the AI need to be aware of? Does it, what objects can it interact with? Like if it's a crate that has physics on it, can it interact with that, or do we want it to avoid that? So that's one part of it. The complexity of detection, like how far can it detect? How many kinds of means does it have to, can it hear the player? Can it see the player? And the level of complexity of those, can ultimately, and the quantity of those. So for example, if you have one AI entity that is searching the space, like that might be okay, but what happens when you have 10 of them? What happens if you have 100 of them going at once? And this is an area where you can run into trouble, because all of a sudden, by having 100 AI agents within your space, you go from what may have been 60 frames per second to all of a sudden you're going sub 30, even 20 frames per second. And part of that is also the update frequency. So you have the number of AI agents, you have how often they are able to see the space, but then within how they perceive the space. But even within that, there is also the complexity of the perception of their space. So yeah, this again, each of these could be a talk in of their own, but at the end of the day, if you're going to be doing gameplay programming, these are kind of two areas that you'll kind of be commonly operating in, which is basically implementing either the player and how they interact or engage with their world, or alternatively, implementation of the AI agents or NPCs, non-playable characters that occupy that world. Right, that brings us on to engine programming. And again, this could be a talk in of itself. But the analogy I would like to use is, if to some extent the artists build the sky, then the engineers provide the ground, but they also provide the fundamentals for how artists can visualize those things. And the common way of doing this, and now we are getting incredibly in-depth, incredibly low level here, is basically there will be what we call graphic APIs, which are kind of libraries that we can use to effectively visualize the world that you see on the computer. And the common ones are DirectX, which is from Microsoft, and then you have OpenGL and Vulkan, which cross-platform and open to use, and then you have Metal, which is specific to Apple devices. And the main reason I'm discussing each of these is because ultimately, to some extent, depending on which discipline that you're in, but also if you are building an engine or you're part of an engine team, there's a good chance that you will be using one of these APIs to build the world. And to touch on, like, these are used to render the world. It commonly used format for like characters or 3D objects is like an FBX, for example. And like with those engines, you would need to write how you translate that data of 3D object and visualize it in the world. But not only but it's literally just taking that object but visualizing it. But then you probably also need to write how you apply the 2D texture and apply that onto the object. And like this is very low level stuff. But ultimately, there are individuals who would like to go into engine programming, and this is why I wanted to discuss it, because this is an important part of games. And even at the end of the day, if you use one of the off-the-shelf engines like Unreal or Godot or Unity, particularly with Unreal and Godot, there's a good chance you can get involved at this level. And ultimately, each of these APIs pertain to their specific platforms. I bring up Metal simply because, iPhones and iOS devices, like, they all use Metal, and they are commonly used. So whether you're doing desktop or console development or mobile development, that's when you would know which of these APIs to be using, and which ones you'll need to learn ultimately. But again, these are going to be very contextual to kind of which direction you wish to go in. Then there's physics, and like again, this could be a thing onto itself, but effectively, you would need to have if you were doing engine programming, there's a good chance you would also need to at least define the underlying rules by which objects behave and interact with each other. There are middlewares that do this. So, for example, Havoc is one of the most commonly used middlewares, and effectively, a middleware is something that you can kind of bolt onto the engine that you're building. But within that, it effectively gives you a kind of common way of doing certain things. So, for example, if you have a character and you're using one of these one of these physics elements, it'll be like, okay, I'm giving this thing a mass. I'm, giving it friction or like movement speed, all these. So you get fundamental data types. And again, see, it all connects back to what I was saying earlier. Like the data types that I introduced at the start are used all over the place in these different disciplines. But to use a simple example, in Unreal, you would, you have things like, you have mass or movement speed or whatever. But then the benefit of having a physics library is it would give you very straightforward ways of applying physical actions to an object. So it might be, okay, I want to apply a force onto an object, or I want to apply an impulse. You like the main thing to be aware of is if you're going into engine programming, like you are really delving in deep and effectively constructing an entire like foundation for then ultimately you are building a foundation on which a world will be built on top of. Then, and like this is where we really get into the performance optimization side of it. And when it comes to performance optimization, a kind of a simple way that, well, I say simple, but a way that we break it down is frame time. So, for example, we'll have 30 FPS, 60 FPS, and a simple way of explaining how that works is when it's 60 frames per second, it is literally 60 frames within the time span of one section. Sorry, in 1 second, excuse me. And to some extent, when you are within the context of that, you have that frame time is going to be an aggregation of a variety of different factors. In Unreal, you have something called a game thread. You have a render thread, and it is and you'll have graphics thread, and it's the aggregation of those different elements that ultimately construct your frame time. So like from a performance optimization standpoint, and why in engine programming you need to be aware of these things is because each of these elements ultimately, it's the aggregation of those that can have an impact on performance. If you take the CPU, for example, you have tick or update. So that is how often you are processing all of the logic. GPU would be a simple example would be draw calls. It's like how how many objects are being drawn within this different within this time, and how many if you're rendering 20 objects, 30 objects, but like 15 of them are kind of the same thing, we would implement something called draw call batching, where effectively it's, hey, we are doing this object, this one object here, we're doing it 10, if you're doing 20 crates and they're all, static and they don't do anything, it's incredibly inefficient to be rendering each of those, when instead you could render one and then apply it and instance it between all the positions in the world. So that would be an example of like how, from a GPU standpoint, where you could do performance optimization. When it comes to something like memory, for example, it's like, how large are the objects that we're containing in memory? If you have a player character that has over, I don't know, like 1,000 pieces of information on it, and the game is having to process that every frame and having to update that could lead to a slowdown. And then this goes hand in hand with storage, because ultimately it's the size of your objects on disk, and with the size of those objects, ultimately they have to go through the CPU, and then those go into memory, and then the game is running those in real time. And like a simple example is with storage, it could be anything from player data to the world data, and like how often are you saving to disk? How often are you having to load and save things and go between the storage, the CPU, and the memory, and how often is that exchange happening, and like how much stuff can you retain in one part, or how can you effectively how do you split that data up ultimately? Then you have input devices. So this would be your IO. So this could be like a gamepad, keyboard, or mouse. And like you would have to hook into the operating system, or rather the calls from the operating system for how you get your inputs and things like that. Or rather, you even have multi-input support. So it could be that you have 4 gamepads that you need to connect up to a single device. And the last one you'll see I have here is polling. And polling is basically how often the game is listening to the input device that's if you're only listening to an input device once a second, that will lead to an incredibly latent game, as in terms of it will feel horrible to control, because the player is only able to make one movement a second, or one input a second. There's a lot in here, but I think the key takeaway is the fact that when we're talking about things like frame rate is ultimately made up by a frame time, and that frame time is the aggregation of the different elements. And effectively, it kind of becomes a game of how low can you get, how fast can you make each of those elements such that the target number you're trying to hit doesn't slip. Then we've got the profilers, and again, this goes hand in hand with performance optimization. Some engines that you use will have a frame counter and a frame time, and like those can be used as live metrics. For example, in my game that I've been working on, it might be when I look at the planet and like all of a sudden I notice that frame counter go down. I'm like, oh, that's not good. And then I'll be looking at things like, okay, what is the thing causing? Is it the game thread? Is it the draw calls? Is it the GPU? Like, what is the element that's causing the slowdown? So that's one way of doing it. And in a way, it's a little bit like what Digital Foundry do, where you're watching it live and you're watching the performance. The other side of it is you have data snapshots, which is basically a cached file that can then be loaded into a visualizer, like you can see on the right-hand side here. And that effectively is tracking all the information in the game, and you can kind of go through each of those. Right, sorry about that. That was meant to say network and multiplayer engineering. So when it comes to network and multiplayer engineering, effectively, there's the gameplay side and the data side. And from a conceptual standpoint, and these are not the only concepts you'll need, like, it's very, like, these are two simple examples, but there is a plethora of different architectures by which games are built. You'll see at the bottom here, I say it's all contextual, and it's true. The way that you would build something like an MMO or a MOBA or a real-time strategy or an FPS, all very different architecturally speaking. And like high level, sure, it's about synchronizing the game state between different machines, but also it's like, what information are we sending? And, you know, it's the amount of information that you're sending that ultimately, it's the amount of information that you're sending that ultimately can cause things like latency. So, for example, if you're sending too much information between machines, when you like click your mouse and you're expecting something to happen, but then all of a sudden only something happens, you know, 3 or 4 seconds later, that could partially be down to the player's connection to the server, but it could also just be that you're sending too much information across and you have to separate that. So this, again, all these things can be their own talk, but ultimately, like, you know, there's a conceptual side of it and kind of more high level things that you need to think about. But like, then there's also the protocols as well. And the protocols is the more low level way to be handling things. And these are just things to some extent that the engines will have. And, you know, for example, like TCP/IP, you'll have that there'll generally be more network information which is available, but you kind of have to some extent figure out how much you want to leverage that. Whereas you have something like UDP, which is kind of fire and forget, and it just fires packets, and there's an unreliability of like how the data is being handled. So the long short of it is, if you want to get into network multiplayer engineering from a gameplay side, these are the type of concepts and elements that you would be involved with. Then you kind of have the backend side of things. So to some extent, if, for example, I don't know, I swing my pickaxe from a gameplay standpoint, the data side of it would be that the multiplayer gameplay engineer would have provided, hey, like, I have provided the event that fires off when the pickaxe does its thing. And then the person on the data side of it would effectively link the piece of information that would then link to that, the hook, so to speak. But then on the data side of it, ultimately, like, things like string parsing and sorting, so the different kinds of sorts, because as I said, you're dealing with things more from a data aggregation and an analytical standpoint. How you index that information and how ultimately that information gets stored, as in when a match session finishes in a MOBA, they'll present a score screen, but then when that score screen is presented or during the course of that match, that data needs to be constantly like stored and built up, because then ultimately when you build up and store all that information, that is then how you end up in a situation where you've got the summary at the end. But there are some other games which will use things called like heat maps, where heat maps kind of represent the different points on a map where certain actions have occurred. So the data side of it is ultimately keeping track of not only what the player has done, but also how you store that information. And then to abstract it even further, because now we're in the day and age where, you know, you have a game like Fortnite where you can play it on anything from mobile to desktop to your console. And in a way, you have to take that data the person's had on mobile, take that data they've had on on desktop, but also like synchronize it between all the different devices. And the thing is, ultimately, like the person who like implements not only like, I mean, there's like the networking stack side of it, but then there's also the gameplay side of it. But the person implementing the gameplay side of it isn't going to be the person who also is like, oh, I need to also like connect up the analytics or implement that. Like they may have calls that connect to that, but ultimately they're kind of segregated disciplines that then ultimately come together to create a seamless experience. Right. That brings me on to game engines. And again, this is going to be incredibly brief because, again, all of these areas could be talks in of themselves. So just to kind of talk about these things and and in the context of how it relates to programming. So in Unreal, for example, the programming language used for the engine is C++, but even then, it's not even just straightforward as, oh, I need to learn C++, because in Unreal, you also have something called blueprints, and blueprints are kind of a visual way of describing. It is basically a visual scripting language, and the difference is that it's not like which one's better, C++ or Blueprint. It's more like what kind of problem are you trying to tackle, and can you implement something in Blueprint or can you implement it in C++? And it's ultimately choosing which one suits the problem. And then another fundamental part of Unreal is the fact that you're dealing with actors, and actors are kind of your base class, because from to go back to very start where we're talking about things like inheritance, encapsulations like that, actors are effectively classes that can contain data, but even then from actors they derive different kinds of things, such as pawns and characters. And like pawns, for example, are objects that can be possessed. So yeah, to some extent that's architecturally kind of how it's set up. But ultimately, like C++ and blueprints are the things that you'll need to be familiar with. Then that brings me on to Unity. And in Unity, you are, the scripting language and programming language, for that matter, would be something like C#. And C#, you would then use that to create components or scripts, which you can then attach onto game objects. And then from game objects, you can ultimately create prefabs, which are your templates of different things that you can reuse over and over again. And then lastly, you have Godot. And Godot, you have GDScript, but you also have C#. But there are parallels between these two, as in between Unity and Godot. But it's the fact that Godot, you've got GDScript as kind of the scripting language, but you can also use C#. But the difference would be that you have something that you have nodes, and then ultimately it's those nodes which then make up a scene file, and that's kind of the how you would build things. But ultimately, like the main takeaway from this is these are kind of three engines to be aware of. There are many other engines as well that are out there. You have things like CryEngine, for example, or GameMaker. But these are the three, to some extent, that are very commonly used. At least Godot is very much on the rise in terms of its usage. And the main thing is, if you are applying to a company, and they are using one of these technologies, it is just useful to actually take the time out to go through and learn it, because then at least that way it helps you kind of have some level of grounding before you jump in. But one thing that is also not included on here is custom engines, or even then, there may be companies that use their own custom version of Unreal, or custom version of Unity, or custom version of Godot. And unfortunately, like until you join that company and learn the way that they have built their engine, built their tools, that's kind of that's kind of the gist of it. But that's where understanding those fundamental concepts, understanding those fundamental layers and processes, like that's where it's helpful, because at least those things translate to all of these different elements. Thank you all very much. Bless you if you've stuck it out with me and gone through all of the stuff. And yeah, thank you very much. I really appreciate it.
Nice one. Well done. Yeah, that definitely filled the time. But it was dense. It was comprehensive. It had everything in there. Absolutely. We've had just a bit of chatter while we've been talking as well. So just hello to everyone that joined us in the middle of that talk. I hope you got the gist of it as you caught up with us. Let's do a little. What I'll do is let's put this away, and we'll do a little side by side. There we are. All right, husband. Well, yeah, that was very comprehensive, and you've obviously got like a sort of an incredible amount of work history that's sort of really let you get into this stuff, and you've sounds like you've had a lot of experience with it all. You've seen it all sort of happening around you. So I guess really a good first question for you is, other than coming to this event, other than coming to this talk, or let's say you had come to this talk, and you now wanted to pursue. You wanted to learn one of these engines, or you wanted to learn one of the concepts we've talked here today. Are there ways to do that? Are there ways to do it for free? Do tutorials exist for any of these things, or maybe all of them?
That's a really great question, Jonas. So here's the funny thing: is I have previously alluded to I wasn't in games. I got a degree in electronic engineering, and part of that was doing computer vision and graphics, and so to some extent I had a little bit of a grounding in programming, right? So there was a foundation, right, that I had learned. But in terms of the resources that I would say, well now it's very different. Like before, when I learned this stuff years ago, I say years ago, it's 10 years ago now, when Unity was on version 4, and Unreal 4 was this new next-gen technology. Both those companies have created their own learning platforms. I will confess to you all that even though I did Unity, my knowledge of Unity peaked out at around 2017, 2018, so a little bit rusty. But yeah, they have Unity learning platforms, and then Unreal also has its learning platform, so you can go to those. Literally, the way that I learned Unreal was, I believe that talk is now deprecated, but they literally had a tutorial series where they do build things up. They do build things up, kind of taking you from the basics all the way to making your first game. I remember in Unity there was this thing called Nightmares. I don't think that project exists anymore, but my advice would be, to some extent, it is really about. So one, let me just clear the air and say there is no one thing you should learn. I did Unity, I did Unreal, but ultimately there was a lot of there was an element of transfer between both. As in high level, a game is tracking, if I have to get 10 apples, for example, characters, like a top-down perspective, and I'm a little character that needs to collect 10 apples, and that the only difference between Unity and Unreal is the way those things are handled. How does the camera behave? What's the character in Unity? And for those of you who know Unity better than me in the chat, so apologies if I get this completely wrong, but you would have you'd have a game object, you would attach a camera to it, and then within that game object you'd probably want a component of some kind, and you would also need a script that would check has the player overlapped with something, and if they have, is it an apple, and if they have, add 1 to it. And that's kind of one side of it. And then Unreal, it's a little bit the same, where the only difference is you'd probably have a character or a pawn instead of game object, but then you would still attach a camera onto the actor, which is again where the fundamental differences start to happen. But at the end of the day, functionally, it's the same thing. So there are, and like, both engines make use of integers, both engines make use of booleans, both engines make use of floats and vectors. Both engines have the concept of costing. In Unity, you would use array cost. In Unreal, you would use a trace, although technically you have 3 different ways you can do it. But like at the end of the day, there will be these fundamentals that translate between both. And then you also have so bottom TLDR, to answer your very simple question. Yes, there are resources. There's so much that's out there now. All companies, like even for Godot, like they have their learning platforms. There are a lot of tutorials, and I think the main advice I would give is start with the simplest game. That is the biggest thing. Don't think, I'm gonna make I don't know, because I've trained myself now not to get overboard, but
I'm gonna make Red Dead Redemption 2.
There we go. Thank you, Jonas. Thank you. I'm gonna make Red Dead Redemption. No, don't make Red Dead Redemption 2. How about you learn how, okay, I want to make a character from third person. How do I make him walk? Which also, by the way, I just want to add, of course, the simplest version of this is you just have a capsule and you move it around. But the moment that a capsule becomes a character with a rigged skeleton and you have to build animations, that in of itself is an incredibly complicated thing. So simplest version of that would be capsule, learning how to make a camera that feels good, that goes around that, making sure that the inputs, keyboard and mouse, gamepad, making that capsule move. And then that is it to some extent. You almost want to strip down what that complicated thing is to the most simplest form. So yeah.
Nice. And that's definitely that's advice that I've implemented myself. Did a game jam last year, and I remember first time ever using Unity, and one of the first things we did was we just went right, let's make a square touch a circle, and when the circle gets touched, the circle disappears and high score goes up by 1, and
right.
we started with one problem at a time. Make square move.
Exactly. That, and that is the literal that is exactly that is procedural abstraction in a nutshell. It is taking a large problem, breaking up into a series of smaller problems, and then combining it together. And then that is how you make the whole, rather than it's I'm going to make this large world and this animated character and physics and all of this stuff. To even give a better example of this is just or not better rather, but another example. But just look at something like the first Mario game, or look at the original Pac-Man. Look at those games and make those, because ultimately it is the things that those games did is very relevant to games now. And in a way, how I went through the fundamentals of programming, there's also the fundamentals of gameplay and game development. And if you go back to what those games were things like Space Invaders and Asteroids, you will find there is so much in there that translates to modern games. And it's a nice way of learning how to scope down and kind of build the most minimal and fundamental idea first before you then tackle the larger things.
Nice. There is a question in chat which I'm going to ask, and then just looking at the time as well. So if anyone does have any questions for us while you're watching this, please do ask them immediately. Ask them as soon as you possibly can, because we're just going over time. So just want to make sure that we give everyone a nice break and a chance to go and live their Wednesday afternoons. But the question I have at the moment, I can bring it up on screen actually for us all. Kevin Goldsmith asks, I suppose, from the perspective of programming, from the perspective of coding a game, are there things that you need to consider, or what do you need to consider when you're making a game for multiple platforms?
Ooh, this is a really loaded question. So,
Go for the, as always, I think let's go for the TLDR.
oh, that is a whole other can of worms. Yeah, all you need to consider. Okay, we're gonna skip the part where you're building your own engine because we're not even gonna touch that territory. So, I think it really one. It depends on variety of factors. So I guess if one, I guess I could put it to, excuse me, two categories. One would be input. One would be performance. So from an input standpoint, hey, all of a sudden, if you're putting your game on a console, even though it's kind of changed a little bit in this day and age, but if you're putting your game on console, for example, you need to make sure your game input works with a gamepad. It's not like an engine, like even one of these engines, like Unreal, Godot, whatever. You have to figure out how you implement your menus with a gamepad versus a keyboard or mouse versus touch input, which I haven't even gone into because, like, hey, if you want your game to run on mobile and desktop and console, you have to figure out how to translate your game, translate your menus, translate all of it to suit those different inputs. And designing for all three of them is a very different ball game. Like, even though it's just like, yes, Unreal has Android or iOS support, or vice versa with Unity. Like, so input, I would say, is one side of it. Performance is the other consideration. If you have an Android phone that's from 5 years ago, and then you also like have a game that is running on a 4090, this is such an extreme example, but obviously there's such a such a power disparity that performance is definitely an area that quite a few developers get caught out on, but sometimes it just can't be helped, or sometimes you don't realize you're going to be working with a certain platform until it gets announced or just mysteriously appears out of nowhere. So yeah, I would say performance and input are main considerations. However, if we start talking about like, oh, I want my game on consoles or whatever, that is an entire separate thing altogether, because it is not like, and I mean, I say it's not even like mobile, but I would say putting your game on mobile, even though you can get the APIs or whatever, like it is not just a straightforward process. The more platforms you have to move your game to, the more considerations you have to make, the more complicated it makes making the game.
Cool. Thank you very much, Kevin. Thank you for the question. I hope that gives you something to go on. I hope you're not making a game for an Android that's over 5 years old. I think that's the bottom line for any game being made.
By the way, it's not to throw shade at Android or anything like that, but the bottom line is, if if you're making a game for mobile, like it's just like, okay, it's not like everyone's going to have the latest device. Like, you have to look at what the majority of users, and like that goes for all platforms. You have to think about like, what's the min spec, but then like, who are you ultimately trying to reach and things, and it just becomes a very complicated mess.
Yeah, no, totally get it. There are a few more questions. Husband, how are you doing for time and energy? Are you okay? Because if we're reaching,
I'm good to just go over a couple more questions, and then
cool, because there's two questions in chat, and I think
yeah.
they're both good questions. So I think if we get any more questions after than that, we'll just close it off here. So two more questions for you. The first of these two questions comes from a Ralph. I'm going to butcher this. Ralph Bierig. Sorry if I say that wrong. What do you believe is the most important skill from computer science that translates well into games? And they also say sort of skill can also mean concept, skill or concept.
Yeah, I think again, a loaded question and this is to some extent why I structured my talk in the context of like, here are the different disciplines. Because like, if you have no interest in network or multiplayer implementation or whatever, like, you don't need to learn it. Like, that is a very specialized field. In terms of like, if I had to summarize it very simply, problem solving. One of the things that, and I mean, I know that seems like a cop out. I know that seems like a cop out answer, but part of the reason I say that is because, simple example, in the world of automotive, in which I did a stint in, right? In automotive, you have a car. That car will have four wheels, and that it's a very understood thing. A car does X, Y, and Z. It has four wheels. It has a chassis. Whereas in games, the terrifying thing about games is you can do whatever you want. The virtual world is you can do so much in it, and obviously that's constrained by your hardware or whatever. But that's the terrifying thing, is how you can express things in games can really, unless you know the type of game that you're building. So really, I would say having a flexibility in problem solving, and really that problem solving, as I said, is going to be contextual. But to go back to fundamental things that I think are important, I think things like pseudo. So to me, it'd be pseudocode, procedural abstraction, and to some extent, it'll be the application. Just the simple example of how I had the character, and from that character, I made a player, a goblin, a monster, or whatever. But realizing how to apply those things, it is really problem solving at the end of the day. And to some extent, the unforgiving thing about games is sometimes you don't know what the problem is until it springs on you. Simple example, in my game, we had a bug where if the player's ship collided with another ship at a certain angle, it would lock the player out of input. And how do you plan for something like that? That's the unforgiving thing about games as well, is the fact that, it's also exciting because it's emergent and it's something you didn't plan for. But ultimately, it's the fact that there will be things that manifest as a result of all these pieces coming together. I think ultimately it's just you really do just need to have a flexibility in problem solving, and you just kind of have to run and gun it, so to speak.
Yeah, no, great, good answer, and it's a good skill to have in a lot of cases, that flexibility, but sounds like more so in video games. And then finally, and it might be a similar question, but it looked good to me, so I'll ask it nonetheless. Tyler Charman Smith has asked, so I guess firstly there's a mini question of, have you ever worked in software or web development? But I think even if you haven't, I'm sure you're aware if there are or are not any similarities to game development, whether it's their development processes, their workloads, etc.
Yeah, so so as I said, my background's in electronic engineering. I did do software engineering for at least I guess it'd be 5-6 years before I then decided to make the plunge into game development. Or there was a period where game development was a hobby for me, and then it translated into a job. So I would say yes, there are similarities in that, to some extent, producers are your project managers in the context of, there are all sorts of different roles, but you would have, probably a producer instead of a project manager. We still have, Jira. We still, have Slack. We still use, just for context, it's like, yes, we have issue trackers. Yes, we have, ways of, discussing things. In terms of the development process, yes, there are like, we do have agile and waterfall. As I said, those are, but like, I know I keep going back to those, but for example, in kind of more traditional engineering, we have something called the V model, which is kind of a safety oriented way you would build something. But yeah, the bottom line is, yes, there are similarities. In terms of the workload, I would say probably the difference between the two is the types of problems that you're having to solve. Like, I feel like if you're doing anything kind of, shall we call it, grounded in reality as opposed to in a video game, is grounded reality, you're kind of dealing with things that, to some extent, that have a lot of knowns. You aren't really going to tackle something like there will kind of be a pattern by which you build something. Whereas in game development, as I said, the thing is, there'll be things that can like emerge as a result of how different systems interact with each other. I had a thing from Gary's mod earlier in one of my slides, and that's simply because we've all seen what happens if you use something like the gravity gun, and or even in some open world games where your character trips and then all of a sudden you get launched into the air. When you're kind of dealing with real world problems, don't necessarily need to worry about that. If you're dealing purely in data, in apps and things like that, don't really need to worry about that thing. Only need to worry about how straightforward it is and kind of how you kind of like let's say the problems are more understood, whereas in game development, the problems can be emergent. And so, yeah, there are similarities, like to some extent. If you're working in a large company, it's to go back to my very early slide on fundamental processes. Like, there are parallels. The only difference is the types of problems that you're having to solve are very contextual and specific in games, as opposed to software engineering or development, where I think to some extent, the long short of it is, yeah, there are definitely like, as I said, problem solving, that kind of thing. But I feel like with traditional stuff, it's a little bit more understood. Whereas in games, depending on what discipline you're in, and because we are literally creating virtual worlds where anything can happen, the problems tend to end up manifesting in very different ways.
Nice. Thank you. Yeah, thanks for covering that. But just by the way, thank you, Ralph, and thank you, Tyler, for your questions. I do hope you found some nuggets of wisdom in those answers. I think that takes us quite cleanly into a bit of a wrap up. First of all, just a huge thank you to you, husband. Thank you for joining us on the Indie Games channel. Thanks for taking all the time to prepare that presentation, for sitting down and sharing all that knowledge with us, and essentially trying to condense what I know for many people is years and years of focused learning and intensive kind of technical education into a tidy sort of 60-minute summary. I know that could not have been easy. So just thank you so much for taking the time to do it and for joining us here.
It's my pleasure. Thank you so much. And I hope everyone in chat found that useful. Yeah.
Yeah, thank you everyone in chat for your questions, for your engagement. Thanks for being here. If you're not here live, then thank you for traveling. Thank you to you in the future for traveling back in time and watching this YouTube video in the humble year of the 2024. I think that about does it. So basically, what happens now with Inter Games? What have we got coming up? We've got all sorts coming up at Inter Games. So if you haven't seen one of these discipline deep dives before, thanks for watching. Just so you know, Indie Games is more than these sort of live streams. We're so much more than that. One of the big things that we are, me in particular, as the community manager, is we've got a wonderful Discord server. Over 9,000 individuals in there, either working in or moving towards working in the UK games industry. It's a really good hub of sharing knowledge and skills and kind of courses and industry events and networking and all these things. There are industry professionals in that space who are constantly asking questions and giving each other support. So if you've got a question that occurs to you after this event, or you're watching the live stream back and you're thinking, darn, I wish I'd asked this question during the stream. Well, don't worry, jump into the Discord. There's a link somewhere down there in the YouTube description, or in fact, I think I can click a button and make a link appear. So there's a URL there for you. If you jump into the Discord, there's a huge community of people there to learn from and ask questions and just generally get involved. And that's how you can learn about other upcoming events that we're doing with Inter Games. Tomorrow we're doing another live stream with Kevin Davey, who is a sound designer who's worked on some really huge AAA video games. We're talking Elden Ring, we're talking Helldivers, we're talking all sorts. Kevin is going to come in and basically just talk a little bit about how they've sort of overcome a lot of negativity in their life and how that's sort of shaped how they work in the games industry, but also sort of how to stay positive despite all of that. Because the games industry, hey, it's not always a positive time, maybe, you know. So just talking a little bit about how to sort of deal with that bombardment of negative experiences, which it is happening, believe it or not. Next week we're doing more discipline deep dives. We're coming back with a marketing discipline deep dive. We've got some portfolio reviews. We've got some more talks. Check it all out. Please do sign up and get involved. I think that about does it. I think. Husband, have you got anything that you just want to say? You just want to say it. You can, maybe you've got an upcoming project slash video game.
Oh, shit.
That you'd like to just let people know that you're working on that thing, or maybe you just want to give any final words of wisdom.
Oh well, I think I think that's enough programming talk in the chat for everyone. I appreciate y'all sticking with us for that. I mean, I'm currently just chipping away at Rogue Eclipse. So if you're happen to like things which go zoom zoom bang bang pew pew, that's kind of a apt summary of the game. Something in the vein of Star Fox. That's currently what I've been working on, and that is currently what my life has been, other than preparing this stuff. But yeah, nice. And I just thank you all for listening and having the patience to go through that, because it's an incredibly dry subject, and I really appreciate that you stuck around to listen to it. So yeah, thank you.
Nice. Cool. That brings us to the end of the event. Thanks for watching, everyone. You've been brilliant. We've been Into Games. Have an excellent week. I'm going to end the stream just there. Bye, everyone.